Welcome to Lab 4, Part A, Determining Salinity from Conductivity Measurements. The process of hydration. The water molecule is often called a universal solvent because of its effectiveness in breaking or hydrating the crystal lattice into dissolved ions. At the molecular level, hydration is the process of dissolving sodium chloride, which consists of positive sodium ions and negative chloride ions in the form of a crystal lattice. Water's hydrogen bond, which is stronger than the ionic bonds, pulls apart the individual sodium chloride molecules, where water's positive pole attracts the negative chloride ions, and water's negative pole attracts the positive sodium ions. This process is called hydration and results in dissolved solids in water. Salinity is defined as the amount of dissolved solids in water. Evaporation. Historically, to determine the salinity of seawater, a sample was heated to evaporate the water and the residue was weighed. The weight of the residue was then used to calculate the salinity. Now, a relatively fast, easy, and accurate method of measuring salinity is using a conductivity meter. Conductivity is based on the fact that the conductivity of an electrical current through a liquid is highly correlated to a liquid's concentration of dissolved solids like sodium and chloride. A conductivity meter measures precisely how much of its battery current is conducted across its two small metal plates when submerged into the seawater sample. Because salt acts as an electrolyte, the measured conductivity of seawater is directly proportional to the concentration of dissolved ions. In other words, saltier solutions will better carry or conduct electric current. The measure of a solution's conductivity is reported in units of Siemens, either microsiemens or millisiemens, where 1 microsiemen equals 0.001 millisiemens. However, while conductivity is directly proportional to salinity, conductivity is measured in Siemens and must be converted into the units of salinity or parts per thousand. The calibration concept. Determining salinity from conductivity utilizes the calibration concept. To convert Siemens, the measure of conductivity, into parts per thousand, the measure of salinity, we must first calibrate the conductivity meter. Calibration is done by measuring and recording the conductivity of solutions of precisely known salinity. These solutions are called calibration standards. The measured conductivity of these calibration standards are then plotted versus their known salinity to produce a conductivity versus salinity calibration curve. By using a calibration curve, we can plot a measured conductivity to the curve and determine the salinity in parts per thousand of a seawater sample. Next, pause the video and watch the video lab experiment posted in your online lab section entitled Lab 4 Salinity Experiment Part A. Now that you've collected your data for the calibration standards, let's walk through an example of how to construct a calibration curve. Let's use the example data listed in the table. First, plot the known salinity values versus the measured conductivity values onto the graph, where the x-axis is your measured conductivity and the y-axis is your known salinity, and then plot the points. Next, using a straight line, draw a best fit line through the data points so that the line fits the general trend of the data points. Make sure that your best fit line extends through the y-axis and crosses the first data point. Next, we will calculate the slope of the best fit line. First, pick 2 points on your line. Point 1 should be close to the origin, and point 2 should be a farthest point from the origin. Then record the coordinates of your 2 points. We will use these coordinates to calculate the slope using the equation of rise over run, where slope equals 0.2 salinity minus 0.1 salinity divided by 0.2 conductivity minus 0.1 conductivity. In this example, the slope of the best fit line equals 0.9. Slope-intercept. The slope-intercept, or also called y-intercept, is the point where the best fit line crosses the salinity axis, or y-axis, on the graph. In this example, the slope-intercept is approximately -0.5. Equation for the best fit line. The correct way to write the equation for the best fit line is in the form of y equals mx plus b, where m is the slope, b is the slope-intercept, or y-intercept, and the variables x and y represent conductivity on the x-axis and salinity on the y-axis. Later, we will use this equation, which contains your calculated slope and estimated y-intercept, to convert measured conductivity values into salinity values. It's now time to complete your lab assignment. Part A, determining salinity from conductivity measurements. Then watch video 3, Part B, make your own solution of known salinity, and please address your questions to your lab TA.